Hello students, today we will start the third chapter. First was physical world, second was units and measurement, and the third is the motion in straight line. So today we are going to start the chapter motion in straight line, and in motion in a straight line we'll start with the two basic thing. One is, I think all of you know, is distance, and the other one is what? Displacement. So basic things we are going to start. What is the difference between distance and displacement? Now I think all of you know distance is what? It is the path or length covered by a body. That is known as distance. Length covered by a body. It is known as what? Distance. And what is displacement? I think all of you know. Displacement is what? Shortest path or length. Shortest path or shortest length, okay, covered by a body. So that means this is what? Displacement. So displacement and distance, we all know these terms, and distance is the path or the length covered by the body, and displacement is the shortest path. Now there is an example that that if you move say 6 meter and then you move 8 meter on this side, okay, are you getting it? Say 6 meter towards north and 8 meter towards east. So what is the distance? Now you know that distance is what? 14 meter. But the same thing if I ask you 6 meter north, are you getting it? And then you 8 meter due to east. What is the displacement? Now displacement is this. This is the displacement. And this displacement is what? Can you tell me? Displacement is what? This shortest. So it will be root 8 square plus 6 square. It makes root 100, and then that is 10 meter. So displacement is 10 meter. So this is an example between distance and displacement. Further we will see that distance, that distance can't be negative. Distance can't be negative. You can't have a negative distance. Whereas displacement can be negative. Displacement can be negative. Distance can't be zero. If you have a travel distance, then there is a distance. Displacement can be zero. You go away from your home and you come back. What happens? What is the displacement? The displacement is zero. One is that distance is a scalar. Now scalar and vector will come later on. Distance is it will come in motion in plane. Distance is a scalar quantity, whereas displacement is a vector quantity. Displacement is a vector quantity. So this is the difference between the distance and the displacement. What? Distance can't be negative, displacement can be negative. Distance can't be zero. So what we are discussing is the distance, the path covered by the body, and the displacement, the shortest path covered by the body. Are you getting it? So this is how we can explain distance and displacement. Okay. Then comes, all of you know, two very important things, and that is what? Speed and velocity. Now we talk about the speed and velocity, like we have talked about distance and displacement. Now speed, we know that simply any speed is what? Distance upon time. We say that distance covered in some time, distance per unit time, that is speed. Whereas the velocity, we say it is the displacement upon time. The rate of change of displacement, we say velocity is displacement. We know that speed is what? Scalar. Speed is a scalar quantity. Are you getting it? Same velocity is what? A vector quantity. Velocity is a vector quantity. Remember, this is a vector quantity. So these are the basic things which we are going on. And then you know that speed can't be negative. You can't have a negative speed. You can't have a negative graph. Velocity can be negative. When a ball is going what? Changing its speed and coming down, then how the velocity is be negative. So velocity can be negative. So these are the cases where we know that speed, okay, and speed is a scalar quantity, speed can't be negative, and speed is a scalar, velocity is what? Vector. Now when we talk about the speed and velocity, we say that sometimes speed is the magnitude of velocity. Now speed, if I ask you types of speed, now types of speed we are and types of velocity. Now similarly, what are the types of speed and types of velocity? Types of speed. If I ask you what are the types of speed? Types of speed, you have heard about generally 4 types of speed. One is what? Uniform speed. Okay. Second is what? Variable speed. That is also known as what? Non-uniform speed. Third is what? Average speed. And fourth is what? A word instantaneous speed. These are the 4 types of speed. Whereas when we talk about the same way, we have types of velocity, uniform velocity. I think all of you know what is uniform velocity. Equal distance traveled in equal interval of time. And then we have a variable velocity, that is also known as non-uniform velocity. Third is what? Average velocity. Net displacement upon net time taken. And fourth is what? Instantaneous, at an instant, instantaneous what? Velocity. So velocity are of what? And speed are of what? 4 types. I am not going to dictate their definitions. You can write their definitions, but I will give you some concept of average speed, average velocity, instantaneous speed and instantaneous velocity. Now we are talking about what? Average speed and average velocity. We'll talk about that. Now I think all of you know average speed is actually what? The total distance upon total time. Upon total time. Are you getting it? Say this is A point, this is B, and this is C. We know that distance traveled D1, D2, time taken from A to B is T1, time taken from B to C is D2. So we know that average speed, if I want to find out it will be what? D1 plus D2 upon what? T1 plus T2. It can be written in this way. So this is average speed. Okay. And then we talk about the average velocity. Average velocity is what? Average velocity, if I want to ask you about average velocity, it will be what? x2 minus x1 upon t2 minus t1. You know that you need a net displacement. Are you getting it or not? So average velocity is, this is the time interval, and this is also known as net displacement upon net time taken. That is average velocity. So this is average velocity, which we say that net displacement upon what? Net time taken. You can calculate the average velocity also. Are you getting it? Say the same example I am taking, that you went 6 meters towards the north and 8 meters towards east. Are you getting it? This is A point, this is B point. So find, if I ask you, average speed and average what? Velocity in time 2 hours. Now I think all of you know this is a very simple question and how to solve it. Average speed is what? Total distance. Now total distance is 6 plus 8 upon time is what? 2 hours. So it is 14 by 2. So it will be 7 meter per second. But if I ask you average velocity, I think you will come to know what is the displacement. This is the displacement and this is what? If you do it, it will come 10 meter. If I ask you what is the average, it is 10 by 2. So it is 5 meter per second. Are you getting it? So in this way you can find out the average speed and average velocity. Okay. Now we'll talk about average. We have talked about, then we have instantaneous speed and instantaneous what? Instantaneous speed and instantaneous what? Velocity. So same way we can have instantaneous speed and instantaneous velocity. So we know that like instantaneous velocity. Now if I ask you what is instantaneous velocity? Instantaneous velocity, we know that average, and average is taken for total displacement upon total time taken. But that sometime the time interval is for instant. So what will happen? Now that average will become what? Instantaneous. So we can write the velocity at an instant is defined, okay, as the limit of the average velocity. We define it like this: average velocity as the time interval. Time interval is very small, as the time interval. Are you getting it? Time interval, what is small, that is delta t, becomes what? Very small, infinitesimally what? Small. That is known as what? Instantaneous velocity. So see the definition at an instant. So if I ask you velocity limit what? Delta t tends to 0, del x by del t. I know all of you know del x, delta is a small term. It is a Greek word for small values. So this velocity further it written as dx by dt. Dx is also a small displacement. Delta is also, when you put delta in front of any quantity, it becomes small, or delta is del. You put dx, so delta x can be written as dx. So this is how we write for the small quantity instantaneous velocity. And in the same way we write instantaneous speed also. Here only I am writing instantaneous speed. Speed is the magnitude. If write instantaneous speed. Instantaneous speed will be the same way. Say we say s, we are denoting, it will be delta x by delta t. Okay, limit delta t tends to 0, or speed can be what? Delta x by delta t. So this is the instantaneous speed or instantaneous velocity. So this is velocity and speed, and then comes what? We'll talk about the acceleration. Now I think all of you know what is acceleration. Acceleration is basically, it is the rate of change of what? Velocity. I think any acceleration, we know that it is a velocity upon time in general form. But then acceleration, we take what are the types of acceleration. So types of acceleration, again there are 4 types. One is uniform acceleration. Are you getting it? When you have a constant acceleration, then we have a variable acceleration, changing acceleration. When the acceleration is changing, then we have an average acceleration, like we have an average velocity, and then we have instantaneous acceleration. Instantaneous what? Acceleration. Are you getting it? We have 4 types of acceleration. So same way we are going to define about the acceleration, types of acceleration. And I think all of you know when we talk about what average acceleration. Average acceleration. Okay. So we know that average acceleration will be the velocity, okay, net velocity upon net time. That means I am going to write net time taken. Even I can write average velocity as v2 minus v1 upon what? t2 minus t1. This is an average acceleration. So we know velocity for first interval and second interval. We will find out the time, what will be the acceleration for that interval. And this is an average acceleration. Then we have what, like average acceleration, we have what? Instantaneous acceleration. Instantaneous what? Acceleration. Now for instantaneous, all of you know, the acceleration will be what? Limit delta tends to 0, same way delta v by delta t. Or we can write dv by dt. Are you getting it or not? It will be the acceleration at an instant. So acceleration at an instant of time, when the time is very small, at an instant of time. So this is an acceleration. So A is dv by dt. So average acceleration, instantaneous acceleration. Acceleration is generally what? Unit. You know that SI unit, I think all of you know, it is meter per second square. We have a G, acceleration due to what? Gravity. That's our acceleration. And I think all of you know what is the value of G is 9.8 meter per second square. So average acceleration, instantaneous acceleration. We'll go further on the numerical on these things, but these are the quantities related with the acceleration. Now I will discuss some graph related things, basic graphs, and then we'll move on with the questions of the graph. Are you getting it? So first I am talking about the position time graph. Now already you know that how we define position time graph. Position time graph. So some basic graphs, I am going to draw it at only at one space, how the position time graph. Say this is y-axis and this is x-axis. This is position and this is defining what? Time. Are you getting it? Now see here. This graph, say this is A graph. I think all of you know this graph represents what? Particle at rest. If I ask you what this graph represents, I think all of you know what this graph represents. Tell me, this graph represents what? This represents uniform velocity. Are you getting it? Then if I ask you what this graph represents, I think all of you know this is basic graph where it represents that there is a velocity now what? Decreasing. That is a retardation. And then in the same way, if I ask you what this graph represents, same way this one. Now you know that this is the velocity is increasing in this graph. And then there is a line, but though I think you remember this line, but this is not possible. So not possible because it gives what? Infinite velocity. And I think velocity is basically what? Tan theta. Slope of the graph So if you see A, what A represents? A represents what? The body at rest. Body at rest, particle at rest. What B represents? What if I say what B represents or C represents? B represents what? It represents uniform. What? Uniform velocity, or you can say uniform acceleration. So here we know that it represents uniform what? Velocity. Are you getting it? And then this is what? This, in this particular graph, what it is happening in say C. Now C, the velocity is what? Decreasing. Okay, this is a variable velocity. You can say variable velocity. And then D. D also the same thing, velocity is, but that is increasing. It is also a variable velocity. And then at the last we have E. E represents what? Infinite velocity, which is not possible. Are you getting it? Because 1090, okay, it will make velocity what? Infinite. Are you getting it? So this is not possible. I think all of you know this is velocity tan theta. It represents, this is position time graph where we can get what? The velocity in this case. You know that when velocity decreases, it is a retardation. When velocity increases, it is acceleration. It is a uniform what? Velocity. So these are the graph. Now we will have velocity time graph through which we can find out the acceleration, like position time graph we have drawn. So it is a velocity time graph. Okay. Now I'm going to draw in the same way. Earlier we have drawn what? Position time graph, now velocity time graph. And from velocity we know that velocity, from velocity Vt graph, we can get what? Acceleration, and acceleration is what? Tan theta. Like we are having velocity tan theta from position time graph. Now I am going to tell you one by one. The first is this one. Now this graph, what it represents, I think all of you know that this graph represents A. Say this graph is A. It's what? Constant velocity. So constant velocity means you have what? Zero acceleration. Are you getting it or not? The acceleration is what? Zero here for this graph, because it has a constant velocity. This graph is what? Velocity versus what? Time. So this is velocity time graph. Are you getting it? Now the next one, if I ask you what this graph represents, I think all of you know this is B, say, and B represents what? This is uniform acceleration, constant acceleration. Are you getting it? It's a constant acceleration. A is what? Constant in this case. Okay, and then if I ask you what this represents, this one, say this is C. Now C represents what? It is what? Acceleration is what? Decreasing. You know that we say it is a retardation. Acceleration is becoming negative. So it's decreasing. It's also known as variable acceleration. And then if I ask you what this represents, say D, and D represents what? D represents saying acceleration is what? Changing. It is what? Increasing. Are you getting it? And then the last one which we see here is that this graph, which is not possible. Okay, C is E. E represents what? Infinite acceleration. Again I am repeating why infinite acceleration is not possible. A is tan theta, theta is 90, and tan 90 is what? Infinity. So remember, this is velocity time graph. What we say, rate of change of velocity defines what? Acceleration. So in next We are going to discuss about the numerical based on these graphs, and then the most important case is the uniformly accelerated motion. Okay, so thank you and watch my videos regularly.